Good day, everyone. So I'm going to provide you a discussion on trigonometric equations. So I will be doing this by part. So I will first introduce the lesson today and then continue with the first method on how to solve for trigonometric equations. And then several videos will be posted for other ways on how you would be able to solve trigonometric equations of different forms. Let's begin. So the outcomes of this lesson is for you to be able to define fundamental solution set, differentiate a solution set from the fundamental solution set, and to obtain the fundamental solution set of an equation involving trigonometric functions. So let's first define the terms that we are going to use. First is the solution set, or we just call it as SS. So the solution set of a trigonometric equation is the set of all values in the set of real numbers satisfying the trigonometric equations. While when we say fundamental solution set, or we call that as FSS, this is just the set of all values in the interval 0 to 2 pi satisfying your trigonometric equations. So basically, the point is for your fundamental solution set or FSS, we are just considering all angles satisfying your equation starting from 0 up to 2 pi. So basically, we're just considering one rotation or angles within the first rotation. However, when we talk about the solution set or SS, we are talking about all solutions from the first rotation to the second rotation to the third rotation and so on. All right, we're considering all values across infinite number of rotations. So there are several ways on how we can solve trigonometric equations, and this is the first method, and we'll call this as your solving tip number 1. So we use this tip whenever we have an equation containing a single trigonometric function. Okay, in this case, we first solve for the trigonometric function before we solve for the variable. So basically, what we do for solving tip number 1 is to isolate first your single trigonometric function on one side of an equation, and then later on we will be using the definition of your inverse circular function in order to free the variable. Okay, so that we will be able to solve for whatever value this variable may hold. So to further explain this one, let's have several examples. So let's look at this first example. Solve for the fundamental solution set of the equation 1 plus 2 cosine x equals 0. So looking at our equation, we just have a single trigonometric function involved, which is cosine x. So what we need to do is to isolate cosine x first. We can do that by adding -1 on both sides of the equation and then multiplying both sides by 1/2. And we see here that we end up with cosine x equals -1/2. We know that -1/2 is less than 0. So that means that our cosine, rather our angle, since cosine is negative, our angle x must be in the second quadrant or in the third quadrant. How is that so? Because remember, cosine is negative in the second or in the third quadrant. All right? So now that we know that fact, so take note that cosine theta is equal to 1/2, whenever theta is equal to pi over 3. So we use theta equals pi over 3 as a reference angle so that we will be able to get the corresponding angles in the second and in the third quadrant. Remember, our by definition, when we say reference angle, we are talking about a positive acute angle, okay, which is formed by the x-axis and the terminal side of your angle. Okay, so in the second quadrant, take note that in order for us to solve for the actual angle, we use the formula pi minus theta. Okay, where theta here is our reference angle. So substituting theta in this equation, so we get pi minus pi over 3, and subtracting pi over 3 from pi, we will get 3 pi minus pi all over 3, and that will give us 2 pi over 3. And in the third quadrant, in order for us to get the actual measurement of the angle, we use the formula pi plus the reference angle. Okay, so please take note of these formulas. So they will be explained further during the actual class discussion. Okay, again, for the second quadrant, in order to solve for the angle, that is pi minus the reference angle. And then for the third quadrant, we use the formula pi plus the reference angle. Okay, so in the third quadrant, following this formula, so we get pi plus pi over 3. So we will get 4 pi over 3 after solving. So that means that our fundamental solution set is the set containing 2 pi over 3, the angle that we got in the second quadrant, and 4 pi over 3, which is the angle that we got in the third quadrant. All right? So let's now go to the second example. It's the same question, it's the same given. However, we want to get the solution set, not just the fundamental solution set. So how are we going to do this? So it's actually very simple. So from the first example, we already obtained our fundamental solution set, which is the set containing 2 pi over 3 and 4 pi over 3. Since the solution set contains all possible solutions within the set of real numbers, all we need to do is to get all angles coterminal to 2 pi over 3 and 4 pi over 3, and we include that in the fundamental solution set. So that means our solution set now will be the set containing 2 pi over 3 plus 2n pi and 4 pi over 3 plus 2n pi, where n is an integer. Take note, we are adding 2n pi because we are getting all other coterminal angles for 2 pi over 3 and 4 pi over 3. Take note that n is an integer, and n here tells us the number of rotations or the number of cycles we need in order to get back to the terminal side of 2 pi over 3 and 4 pi over 3. So we're basically just adding additional cycles to get the coterminal angles of 2 pi over 3 and 4 pi over 3. So again, the only difference between your fundamental solution set and the solution set is that for the solution set, you are adding 2n pi for every element of the fundamental solution set. Okay? Again, we are just adding 2n pi for each element of your fundamental solution set. So again, in this example, our fundamental solution set has the elements 2 pi over 3 and 4 pi over 3. For the solution set, we are just adding 2n pi to 2 pi over 3, and we are adding 2n pi to 4 pi over 3. And then don't forget the condition that n is an integer. All right? So let's try to look at another example. So let's see example 3. Solve for the fundamental solution set of the equation 2 minus 3 theta equals 0. So again, we're only one trigonometric function, which is sine theta, is involved in this equation. So we have to isolate sine theta by adding negative 2 to both sides and then multiplying negative 1/3 or dividing by negative 3 to both sides. So hence we will get sine theta equals 2/3. Okay, so since 2/3 is greater than 0, meaning it's positive, then your theta must be in the first quadrant or in the second quadrant because sine is positive on both first and second quadrant. All right, so now we just need to get the value of theta. So take note, however, that we don't have any special angle where sine theta is equal to 2/3. So how are we going to solve for theta? So this is actually very simple. All we need to do is to make use of the definition of our inverse circular function. So in order to free theta from sine, we will need to get the inverse of sine of both sides. Okay? So that means that theta must be equal to arc sine, capital A, okay, 2/3. And we know that when the argument of arc sine is positive, then that means theta is in the first quadrant. Okay? So that means this will be our first angle. Remember, um, theta must be in the first quadrant and in the second quadrant following the previous slides because sine theta is positive. So now we were able to get the angle in the first quadrant. So now, how are we going to get the angle in the second quadrant? So following example 1, in getting the angle in the second quadrant, we use the formula pi minus theta, where theta is your reference angle. But however, from the definition of your reference angle, it is a positive acute angle. But take a look at this. Theta is in the first quadrant. So that means theta is positive. In the same manner, since theta is in the first quadrant, we are sure that it is less than pi over 2 or 90 degrees. That means it is also acute. So it follows that your angle in the first quadrant is already your reference angle. So now, in order to get the solution in the second quadrant, again, that is just pi minus the reference angle. In this case, our reference angle is the same as the angle in the first quadrant. So we get pi minus arc sine 2/3. And this is our angle in the second quadrant. So that means our fundamental solution set is the set containing arc sine 2/3, which is our angle in the first quadrant, and pi minus arc sine 2/3, which is our angle in the second quadrant. All right? So I hope this is clear. So what if we need to get the solution set of the same equation? So we have already solved from example 3 that the FSS is arc sine 2/3 and pi minus arc sine 2/3. So from following example 2, all we need to do is to obtain the solution set is to add 2n pi to each element of your fundamental solution set. So it follows that our solution set will be arcsine 2/3 plus 2n pi. So we have this. And then pi minus arcsine 2/3 plus 2n pi. Remember that pi and 2n pi has a common factor, which is pi. So we're bringing out pi. And then if we factor out pi, then we are left with 2n for 2n pi. And then we will be left with 1 or positive 1 for pi. So that's why we got here the quantity 2n plus 1 pi minus arcsine 2/3. And again, do not forget the condition that n is an integer. Okay, so now let's try some of these examples. Okay, so let's try to solve square root of 3 tangent x minus 2 equals -1, as well as cosine x plus 2 equals 0. Okay, so you may try it first. You may pause the video and try solving it first. And then later on, we'll explain the solution. So now let's look at the solution for each. So let's try to solve this one with the solution. So we just have tangent as your function involved. So all we need to do first is to separate, or what do you call this? Isolate, okay, tangent x. So we can do that by first adding 2 to both sides. So if we add 2, we will have square root of 3 tangent x equals 1. And then right after, we divide both sides by square root of 3. So if we do that, we will be getting tangent x equals 1 all over square root of 3, or that is simply square root of 3 over 3 after we rationalize. Okay? So we know that this is greater than 0. So that means when tangent is positive, then it follows that x must be in quadrant 1 or in quadrant 3. Okay? So x must be in quadrant 1 or in quadrant 3. So now, take note. Okay, so we take note that tangent, okay, is equal to square root of 3 over 3. So I'll just put it here. So note, oops. So note that tangent x, or tangent theta rather, is equal to square root of 3 all over 3 when theta is equal to pi over 6. Okay? Again, tangent theta is equal to square root of 3 over 3 when theta is equal to pi over 6. So this is a positive acute angle, so that means we consider this theta as our reference angle. So now, based on this, in our first quadrant, okay, in our first quadrant, So remember, in the first quadrant, our angle is already positive and acute. So that means in the first quadrant, the value of your angle here is already your reference angle. So it follows that in the first quadrant, our answer is pi over 6. Okay? And for the third quadrant, if you remember the formula, for the third quadrant, it's pi plus theta. Okay? So it follows that in the third quadrant, our answer will be pi plus our reference angle pi over 6. And this will give us 6 pi plus pi all over 6. Okay? So, simplifying this, we will be getting 7 pi over 6. 7 pi over 6. And that is our solution for the third quadrant. Therefore, our FSS must be equal to the set containing pi over 6 and 7 pi over 6. Alright? And aside from that, it will also follow that our solution set, so we'll just copy this. Our solution set will be the set containing the elements of your FSS, and we are just adding 2n pi or 2 pi n if you want. 2n pi or 2 pi n will be acceptable. And then plus, this one we also add 2 pi n. Again, where n is an integer. And those are your answers for the first one. All right? So now let's try to look at our second problem. We want to solve for cosecant x plus 2 equals 0. Okay? So, again, since only one trig function is involved, so we are going to just segregate or isolate cosecant x. So we can do that by adding negative 2 to both sides. So we will get cosecant x equals negative 2. However, take note, by reciprocal identity, cosecant is just sine. Okay? The reciprocal of cosecant is sine. So since we get the reciprocal of cosecant, we'll also get the reciprocal of their values. So since cosecant is equal to negative 2, then our sine x will be equal to negative 1/2. And this is less than 0. So it follows that x, that x is in the third quadrant. Again, sine is negative in the third quadrant or in the fourth quadrant. All right. So now, again, we just have to get now the answers or the angles for which sine is in the third quadrant and in the fourth quadrant. Okay. So again, we note, control I, we note that sine x. So here we're now using sine x instead of cosecant x, because again these two share the same angle. Okay, so note that sine x is equal to 1/2 when, I don't know why it changed color. Let's use black. So I'm sorry, here sine theta rather is equal to 1/2 when theta is equal to pi over 6. So again, pi over 6 here is our reference angle. Now we want to get its counterpart in the third quadrant or in the fourth quadrant. So in quadrant 3, in order for us to get for the value of x, again, the formula would be pi plus your reference angle theta. Since we already know the value of our reference angle, so we just add pi over 6, and we will get here, again, 6 pi plus pi all over 6. And this will yield 7 pi over 6. So this is our angle in the third quadrant. However, in the fourth quadrant, so what do you think would be the formula? So the formula would be 2 pi minus the reference angle. Okay? So in the fourth quadrant, if we wish to get the value of x, that will just be 2 pi minus the reference angle. So in this case, we're going to have 2 pi minus our reference angle, which is pi over 6. Okay? And solving for that, we're going to get 12 pi minus pi all over, sorry, this is wrong, over pi over 6. Okay? And that will give us 11 pi all over 6. So in case you're wondering, how am I getting this? So remember, when you're adding a whole number in a fraction, so you multiply the denominator with the whole number. So 6 times pi is 6 pi, plus copy the numerator rather, of your fraction part. So we get 6 pi plus pi all over 6. In this case, we have 6 times 2 pi, so we get 12 pi. And then minus the numerator part, which is pi, all over the denominator, which is 6. So 12 pi minus pi all over 6, that is 11 pi over 6. So it follows now that our fundamental solution set is the set containing 7 pi all over 6 and 11 pi all over 6. Okay? And our solution set will just be the set, okay, 7 pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n, where n is an integer. Okay? And those are the answers for the try exercises. So on the next video, we're going to talk about the second solving tip. But for now, try to understand first how to do solving tip number 1, because we will also be using that in the other tips that I'm going to introduce. Thank you for listening, and I'll see you on the next short video.